So this lesson is on the chain rule, looking at it from the perspective of functions, that the derivative of some function f of g of x is f prime of g of x times g prime of x. So let's take a look at a couple examples. If I want the derivative with respect to x of the cosine of x squared plus 3. Well, what is the outside function? The outside function is cosine. The inside function is x squared plus 3. So we would say g of x is x squared plus 3, and f of x is cosine x. So then what is f prime of x? The derivative of cosine x is minus sine of x. And how about g prime of x? Is the derivative of x squared plus 3 would be 2x. So the derivative with respect to x of cosine of x squared plus 3 is the derivative with respect to x of f of g of x which is f prime of g of x times g prime of x. And let's go ahead and look at this. What is f prime? F prime is negative sine of something. So f prime of x is negative sine of x. What's f prime of g of x? F prime of x is negative sine of x. F prime of g of x would be negative sine of x squared plus 3. So we can put that in here, negative sine of x squared plus 3, times g prime of x, which is just 2x, and writing this in a little cleaner fashion, we'll finish it up with negative 2x, times the sine of x squared plus 3. Now, that's a little more formal, frankly, than most students like. So let's do this again with a somewhat less formal approach. So we're going to look at the derivative with respect to x of the cosine of x squared plus 3. The derivative of the outside function is negative sine of something times the derivative of the something. That's typically how I do this. So the something, of course, being x squared plus 3. The derivative of the outside function applied to the inside function times the derivative of the inside function. So what this becomes then is negative sine x squared plus 3 times 2x. And then we go ahead and write it as negative 2x times the sine of x squared plus 3. Let's do another in that vein. What is the derivative with respect to x? Show our power rule kind of approach, right? What if I have the derivative with respect to x of x squared plus 4x plus 1 to the 17th power? Well, this is the derivative of something to the 17th power, which would be 17 times something to the 16th power times the derivative of the something being x squared plus 4x plus 1 times the derivative of x squared plus 4x plus 1 as we untie these composed functions. And we get 17 times x squared plus 4x plus 1 to the 16th times the derivative of the inside. Derivative of x squared is 2x, derivative of 4x is 4. And I'm going to leave it in that form just to emphasize the behavior of the chain rule. So this is the approach I typically use. Let's take a look at a few more. What is the derivative with respect to x of 1 over two x plus 7. Now you could use the quotient rule here, but you don't have to, right? This is the same thing as the derivative with respect to x of 2x plus 7 to the negative 1 power. And then we ask ourselves, what is the derivative of something to the negative 1 power? That, of course, is -1 something to the -2 times the derivative of the something. The something being 2x plus 7 times the derivative of 2x plus 7. So what we get here is we get -1 times 1 over 2x plus 7 squared times the derivative of 2x plus 7 is 2 plus 0 is just 2. So upstairs we have -2. Downstairs we have 2x plus 7 squared. And notice we could also use this to find the derivative of secant or cosecant, which we've done previously with the quotient rule. Let's do it here with the chain rule. So if I want the derivative of cosecant x, for example, which is the derivative of 1 over sine x, which is the derivative of sine x to the -1. So what's the derivative of something to the -1 power? Is -1 something to the -2 times the derivative of the something this time being sine x. So we get -1 sine x to the -2 is 1 over sine x squared times the derivative of sine x, which is cos x. Upstairs, negative cos x. Downstairs, sine x squared, which I'll write as sine x, which is -1 over sine x times cos x over sine x, just to get it to match what we typically memorize, which gives us -1 over sine x is cosecant x. Cos x over sine x is cotangent x. Negative cosec x, cotangent x. So that's our idea. A couple more for practice. What is the derivative with respect to x of the square root of tangent x, for example? It's only defined where tangent is positive, so we'll say, for the sake of discussion, x is bigger than 0 and less than pi over 2. Just to make sure that this is well defined there. So I'm going to rewrite this as the derivative with respect to x of tangent x to the 1/2 power, which is the derivative of something to the 1/2 power, which would be 1/2 something to the -1/2 times the derivative of the something. That's how I like to think about it. So it is the derivative of tangent x is 1/2 tangent x to the -1/2 times the derivative of tangent x. What does this become? 1/2 times 1 over tangent x to the 1/2 times the derivative of tangent, which is secant squared x. You want to memorize that. So upstairs, what do we have? Upstairs, we have secant squared x. Downstairs, we have 2 times tangent x to the 1/2, which would be 2 times the square root of tangent x.